So I'm Sarah Ambrose. I'm a product engineer on the GeoAnalytics team, and with me is Noah, another product engineer on our team. And we're going to be talking about GeoAnalytics Server today. So this is big data in ArcGIS, an introduction to ArcGIS GeoAnalytics Server. So quickly what we're going to go over today, what is GeoAnalytics Server? Does anyone here know what GeoAnalytics Server is? Okay, a few hands. Has anyone never heard of it at all? Cool, awesome. Well, everyone will learn something today, hopefully. We'll go over the analysis capabilities, data integration, what type of data you can use with GeoAnalytics Server, system requirements, and then we'll definitely have time for questions, so save those to the end, and we will definitely get to them. We're also available at the island all day, so if you're in the showcase, there is a GeoAnalytics booth that we're available to answer any questions, and we'll be there right after the session as well. So a lot of the times people don't really know what GeoAnalytics Server is for or why they would use it. And something that's kind of hard to understand is when would I use GeoAnalytics Server, but it's also what problem are you solving? So a lot of the times with GeoAnalytics Server, that problem is how do I make sense of a large amount of data? So you have a huge amount of data, you don't even know what you're looking for, so GeoAnalytics Server is one of those first steps to start summarizing and looking at that data of interest. So what is GeoAnalytics Server itself? So GeoAnalytics Server is a server role that distributes computing to quickly analyze large amounts of vector data and tabular data across multiple servers. So this isn't a raster solution, but it is for point, line, polygons, and tables. Most often this is point data. That seems to be what frequently accumulates the most. And to you, as a user of this tool, it's a collection of analysis tools. So this is really a toolbox that we provide that's distributed across one or more machines and cores. And these toolboxes are used, or these tools in the toolbox are used to identify patterns, relationships, anomalies, and incidents in large amounts of data across space and time. So why would you use GeoAnalytics Server? So a lot of you, I'm sure, are using some applications or workflows right now where you're struggling to complete your analysis in time, or maybe it's not finishing. So GeoAnalytics Server is a distributed solution that's meant to accommodate that. So instead of just using one machine, you're able to use one machine with many cores, or maybe 3 machines with many cores as well, to distribute that analysis and speed it up and accelerate it. You might not have big data today as well. You might have data that you've started maybe accumulating in GeoEvent, but you know it's growing and you know you're going to have a need for a big data distributed solution in the future, and you need to be able to manage and analyze that data. Similar, you need to distill your data into something more manageable to use in other analysis. So GeoAnalytics isn't an isolated workflow. We're not saying you're going to do all your GIS analysis in GeoAnalytics, but a lot of the time you're summarizing your data and then you're going to use it somewhere else like Pro, where you're able to use all of those tools that are there and available. And lastly, my data has a ton of noise and I want to explore it to bring out what's really important. So it's really about looking at that big data and finding out what's important to look at, how can we find those patterns and trends, and analyze it in GeoAnalytics or use the whole ArcGIS platform to continue your analysis. So GeoAnalytics leverages spatiotemporal analysis to answer questions like, and these are just a few examples of questions that you can use. Using billions of emergency calls accumulated over the past decade, which counties have the largest number of calls per square mile? Which stationary pressure sensors in my pipe network have experienced anomalous events in the past 24 hours? And are there hotspots of those? And where have delivery trucks traveled, and where is the highest density of unique delivery truck paths? Where do delivery trucks travel the slowest? GeoAnalytics is spatial by nature. We are Esri, but we do work with tabular data as well. So a stationary pressure sensor could be a repeated measurement over time, and we still have tools to analyze that type of data set. So what are those actual analysis capabilities that we provide? So we have a few different groups of tools. We've divided them into tool sets, and that's really just to conceptually help you understand what those tools are. The first is summarize data, and this is the one you're usually going to use first. So this is taking that big data and summarizing it into something more manageable, usually a visual representation so that you can understand some underlying patterns. The ones in blue, these are new tools at 10.7, so these will be released in the next month or so. I'm not going to go through each tool. We can definitely talk about individual tools at the island, but there are 19 or so tools, and so that would just be a very long session. I am going to go through 3 in particular afterwards that are unique to GeoAnalytics, but most of these tools are available in desktop today. Not distributed, though. So they're not new GIS workflows. Analyze patterns. So this is when you're not just summarizing, but you're looking for trends or you're looking for statistical significance. And we have 2 new tools here for 10.7. We have forest-based classification and regression and generalized linear regression. So these are 2 tools that are available in Pro today, and then we've created a scalable version for bigger data sets across multiple machines. Find locations, so you're finding particular points of interest or particular features of interest, as well as geocoding your addresses into XY locations, which can be used for other analysis. Use proximity, which is not very exciting. It's just creating buffers, but it is there if you want to create a lot of buffers. We have data enrichment. So this is a new category that we've added at 10.7, where we're able to enrich from a multivariable grid. I'm going to talk about what a multivariable grid is afterwards, because that is a tool that's very unique to GeoAnalytics and a big data solution. And lastly, manage data. So this category isn't really data management, but more your typical GIS tools, overlay operations to get and understand the data that you're interested in. So I'm going to go over 3 tools in particular. These are kind of 3, I don't want to say are like coolest, best tools, but they are the ones that are more unique to GeoAnalytics and specific to more big data solutions. So the first one is join features. So this is very similar to a spatial join. A spatial join being, you can join points to polygons, for example, very common GIS workflow. Join features, though, because big data is often accumulated over time, we're often interested in space and time. So join features allows you to join something in space, in time, and by attributes. And so what that means is I could find a location or a feature that is maybe 10 kilometers within another feature and that occurred within the last 10 minutes. You don't have to use all of these relationships. You could just say join by location, just join by time, or you could do 2 or 3 of those. I have a diagram here with 2 examples. So the first row, I have a target layer that is a polygon over an interval of time. So imagine a polygon, and it happened between January and March. I'm then joining a point data set that's representing an instant, so a single moment in time. And at the end, I'm I'm joining the point data to the polygons that occurred within that time and that space. Below that, I have the opposite. I'm joining a polygon data set to a point data set, and that's just to show you that this goes with all of the relationships. So you can join points to polygons to lines, whatever order you want, and there's a whole bunch of different temporal relationships. I believe there's 13 or so. So something occurred afterwards, something occurred within, there's 13. I'm not going to go through all of them, but there are a bunch of those, and we can walk you through those too at the island if you're interested. The next tool that's really popular is Reconstruct Tracks. So GeoEvent has a big tie-in with GeoAnalytics because a lot of the times we're seeing accumulated data is ingested data through GeoEvent. So Reconstruct Tracks takes those point locations, often a GPS measurement, that have a timestamp, and it sequentially orders them. So here we have some blue and purple points in time and space, and we're able to say some kind of serial ID. So in this case, purple is one track and blue is the other, and we're able to create a line out of that segment. So a few examples are hurricanes, ships, and airplanes. We definitely have these demos, and we've shown them in the past. They're available online. They're available at our island. We can walk through those, but these are really popular examples. And here's an example of what a hurricane track would look like, for example. So instead of just doing the tracks, we can also apply a buffer, which makes a polygon, but that's really cool for visualization. Here we've probably buffered by wind speed to kind of see the effect of the hurricane. And then the last tool is the build multivariable grid. So this was new at 10.6.1. And this is a way of aggregating multiple data sets into one. So aggregate points is a tool that's really popular. You're able to aggregate points into bins like squares or hexagons just to see the count or summary statistics. Build multivariable grid allows you to do that with multiple data sets at once and also calculate different statistics. So instead of just counting the number of points within an area, you're able to calculate things like the distance to the nearest. So maybe the distance to the nearest fire station, the attributes of nearest. So what is the name of the closest fire station? The summary of intersecting, so find the sum of population in that area, and then summary within a given distance. So not just what's intersecting, but what can I find within 20 kilometers, for example. And this is again on one or more layers of interest. So instead of just looking at one data set, you're looking at a whole bunch and creating this one data set that represents all of these attributes. What this is actually good for is, of course, visualization. That's what aggregate points is really popular for, but visualizing a whole bunch of data sets in one is very nice. And that was kind of the 10.6.1 stage of this tool. But now that we've introduced new statistical tools, this can also be an input for those tools. So if you're using generalized linear regression or forest-based classification and regression, you're suddenly able to calculate all these variables that you can then use for statistical analysis. And then lastly, I mentioned the enrichment layer. When you use build multivariable grid, we create this fast lookup table in the back end, which means you're able to easily join that to a point data set much quicker than you would with another tool. So we're able to say, I have a point data set, I'm getting new points in, join my grid to that, and grab those attributes and put them on the point data set. And you can use that for other statistical tools as well. So what this actually kind of looks like, this is a multivariable grid layer that we have the nearest subway station, for example. So those red points represent the subway station. And at each grid cell, which is a cell size that you specify in the tool, we've calculated the distance to that point. So that's just one attribute on that layer. Then we've also calculated the nearest park. So we're able to look at a whole bunch of different feature classes. We had a park feature class, we had a subway feature class, and we're calculating different attributes on them. So this is looking at the nearest park. You could also do something like what is the attribute or what is the size of the nearest park if that was an attribute on that feature. We have the population per square mile as well, and then the number of complaints. So all of these would be a column in your data set, and you now have all of these variables that you can use as one layer. So to actually use GeoAnalytics, we have a few different places that you can run your analysis. Because we know that some people are using ArcGIS Pro, some people are using Portal Map Viewer, some people are developers and using the REST API or the Python API. So GeoAnalytics Server is available in ArcGIS Pro. When you have a portal with GeoAnalytics and it's enabled in Pro, or it's configured in Pro, you'll automatically see the GeoAnalytics tools there. So you'll see some tool sets that you just fill out like regular tools, and when you run it, that analysis is run across the cores on your GeoAnalytics server. So to you, the user, it might look like you're just running a tool in Pro, but you're actually running analysis on your server. We also use the Enterprise Portal Map Viewer. So when you're in Map Viewer, you're able to open some tools up. This is very similar to the tools that are available in ArcGIS Online or in Portal today. There's a standard analysis. When you have GeoAnalytics enabled, the GeoAnalytics tools just show up, and when you run those, they will also run on your GeoAnalytics server, and results are returned in your Map Viewer. And then we also have the ArcGIS API for Python. So if you're using the Python API, if you are using server notebooks at 10.7, the GeoAnalytics tools are exposed there, and you're able to run them in your notebooks. And then lastly, the lowest level is the ArcGIS REST API. So if you want to create custom apps or you're just using the ArcGIS REST API now, we do it ourselves. This is how you can access those tools. They're documented in all of those places. And all of those Pro, Portal, and Python API are really built on the REST API itself. So a few focused areas on the analysis capabilities. So one is that we're working in space and time. I know I've mentioned this a few times. GeoAnalytics performs spatial temporal analysis. And the way we do that is you define your temporal input data. So you do not have to have time to use GeoAnalytics. You can just use spatial data. It's just very common to have temporal data as well. So your data can have instants, so like a moment in time. So this could be a GPS measurement of a truck, for example, or an interval, so a duration in time. It has a start and end time. When we analyze the data, a lot of our tools will allow you to analyze time steps. So this, for example, is lightning data. We're not just looking at aggregating the lightning into one location, but we're interested in how it changes over time. And then, of course, because we're integrated with Pro and Portal, you can visualize those results. So all of these images here on the right, they were visualized in ArcGIS Pro, where we're able to slide through our results. So we can also use ArcGIS Arcade in GeoAnalytics Tools. So ArcGIS Arcade was introduced the last few releases for symbology, but we use this as well in GeoAnalytics for many of our tools. So we use these arcade expressions to do a few different things. We have a tool that looks at incidents in a track. So when is my object of interest going faster than 10 kilometers? I can write an arcade expression to say if incident's greater than 10 kilometers. That's just a way we use arcade. You can also use it to calculate a buffer distance, determine which features should be joined together. So in join features, you could do that spatial, temporal, and attribute join, but you can also write a condition using arcade to say maybe feature X needs to be greater than feature Y to be considered in the join. And that just makes the join features even more powerful. And then in our calculate field tool, that's how you calculate the new field expression, or the new field value is using an arcade expression. If you're not familiar with Arcade, it is fully documented on the developer's site. We do have a few extra functions in GeoAnalytics that aren't available in Arcade, such as our track window. So if you're using tracks, which is what we really call time series data, you can look forward and backward and use a window to calculate results and how they're changing over time. And then, of course, we are integrated with ArcGIS Pro, and we can also be used through ArcPy. So you can use GeoAnalytics results as an input to desktop geoprocessing tools. So you've used GeoAnalytics, you've aggregated into a smaller data set, and now you want to go use ArcGIS Pro to expose all those other tools, maybe create maps. And now at 10.7, of course, ArcPy is in the notebook server, so you can also use GeoAnalytics and ArcPy right there in the notebook server. All of your items are automatically created in Pro with GeoAnalytics, in Portal. So those are items that you can use in Pro. Same with Portal. You can continue to use standard analysis, for example. You can also use GeoAnalytics Tools and Model Builder. It's all part of ArcPy and the tool set. And then result layers can be used with ArcPy. All of this kind of says the same thing. It really works with ArcGIS Pro and ArcPy as well. So with that, Noah is going to do a demo.
Cool. Thanks, Sarah. Can everyone hear me all right?
Is his screen up?
Looks good. And all right, I think you're ready to go. So today I'm going to give you kind of a high-level overview of a few different patterns that we see people using when they use GeoAnalytics. So with any analysis, it begins with data, obviously, and GeoAnalytics makes it pretty easy to read directly from big data sources. We support a variety of sources, which Sarah will go over into much more detail after I show this demo. But for now, I have my deployment, my GeoAnalytics deployment running on a few EC2 instances in AWS. And so my most convenient place to put my data right now is in S3. So I have a bucket here called Big Data File Share Bucket, and it contains 5 different folders. The way that GeoAnalytics reads from S3 buckets and local file shares is through a kind of by using subdirectories. So I'll register this bucket with my GeoAnalytics server, and it'll read each of these subfolders as a data set. This means that I can store multiple files in each folder, and as long as each of those files has the same schema, they'll be read as a single data set. Today I'm interested in this big ol' CSV file that has monthly oil production data for all of the active oil platforms in the Gulf of Mexico. And so I'm going to register this bucket so that I can access that data in my analysis. So to do that, I'm going to go over to my server manager application on my GeoAnalytics server site. And I've previously registered the S3 bucket as a cloud store using IAM credentials. So really all I needed to do was provide that bucket name, and it was registered. To create a big data file share from that, all I need to do is go to register big data file share, select the type as cloud store, and then you'll see my cloud stores are listed in this dropdown. I'll select that big data file share bucket and then name it test BDFS. So when I click create, a service on my GeoAnalytics server actually goes through each of those folders in the bucket, and will read through the first 20 records of each of those data sets to discover the schema. You'll see that it says manifest generation is in progress, and this means that it's going to discover the schema, it's going to try to find any geometry information in my data set, as well as any time information. And so once that service is done, we should be able to see those 5 folders that I showed you in the S3 bucket registered as big data file share data sets. So here's my 5 data sets, and here's that oil and gas production data set. You'll see that GeoAnalytics discovered the schema of that CSV. It found that there were 2 fields that had longitude and latitude in the name, so it automatically registered those as my X and Y values. If I wanted to, I could register a field that containing, for example, GeoJSON or WKT, a string of those formats as a polyline or polygon. And then it also found a field called production date and assumed that it was in the format of epoch milliseconds. That's actually not correct. It didn't discover it correctly, but I can easily customize this, or the way that it reads this time information, by providing a format string. So these date fields are in the format of a 4-digit year and a 2-digit month. So I just need to provide this string to tell it how to read that time information, and we're ready to use it in our analysis. So this is all very well documented. So you know, if you get started with GeoAnalytics, it's pretty easy to follow. So now that I have my data set registered as a big data file share, I may want to kind of get an idea of what it looks like, how it's distributed through space and time before I run any analysis on it. And GeoAnalytics, you know, from our initial release, has incorporated a lot of tools that deal with summarization and visualization. One of the most basic examples of that is aggregate points. So I'm going to aggregate my oil well data into bins to see how it's distributed over space and time. So I registered that data set as a big data file share called test BDFS, and it's available as a portal item, so very easy to use. And then I could aggregate this layer into a polygon layer of my choosing, but instead I'll have the tool create artificial bins for me. So this will create a tessellation of square or hexagonal bins, and then aggregate my point data into that. I'll select the bin size of 10 miles. And then, like Sarah mentioned earlier, most GeoAnalytics tools involve some sort of temporal element. So I'm going to aggregate into 2-year time steps intervals, and we should be able to see how oil production in the Gulf of Mexico changed over the last 20 years in time steps of 2 years. So in the sake of time, I've pre-generated this data set. Takes about 45 seconds to run. And then when we get the result, we can symbolize on statistics that we've calculated. For example, here I calculated the sum of monthly oil volume produced in each bin. And then I'll change the time slider to show us only 2 years at a time. And so then we can get an idea of what our data looks like. You'll see we're symbolizing an oil production, and we have all these dark grid cells that represent high levels of oil production. And since the 90s, as we move forward into the current era, we see that a lot of the highest areas of oil production seem to move south into the Gulf of Mexico. So I have a kind of general idea of what this data set is doing temporally and spatially, but I might want to dig into it further to get some more statistically significant assessment of this change. So if you watched the plenary demo of GeoAnalytics, you saw me use Portal to do that with our density-based clustering tool. But to kind of give you the full breadth of how you could use GeoAnalytics, I'm going to switch over to ArcGIS Pro 2.3. So like Sarah said earlier, GeoAnalytics is fully accessible from ArcGIS Pro. I've just signed in to my GeoAnalytics enabled portal in Pro, and then my GeoAnalytics tools are automatically exposed. So that aggregate points tool I just ran, I could do that in Pro if I wanted to. The tools look pretty much just like any other GP tool. But one tool that's unique to ArcGIS Pro and that's not exposed in the portal web map viewer is the Create Spacetime Cube tool. So this tool basically aggregates your data into a netcdf file, which is a multi-dimensional dataset format. And netcdf files are used by a lot of the space-time pattern mining tools in Pro. So one pattern we see users taking when they use GeoAnalytics is using GeoAnalytics to really boil down their data into something that can be utilized by Pro. So not necessarily doing all of the work in GeoAnalytics, but simply using GeoAnalytics to filter out data of importance or aggregate it into something of reasonable size. So I'm going to create a space-time cube from that oil well data so that I can use the data in Pro pretty quickly. So if I go to my history, I ran that job earlier, and I'll show you what the parameters I used. So I've used a feature service this time of my oil and gas data. So we don't only read from big data file shares, you can use hosted feature service as well. I gave the file an output name, and then just like aggregate points, I'm putting a distance interval, which is similar to that bin size I specified with the aggregate tool, and a time interval, which is similar to the time aggregation I showed earlier. And just like aggregate points, I'm calculating the sum of monthly oil volume produced in each bin. And then this will generate a space-time cube that we can use in the space-time pattern mining tools. So I ran this earlier. It took about 1 minute and 25 seconds. And I have this space-time cube stored locally that I can now feed into my Pro tools. So let's go do that now. I'll open up the space-time pattern mining tools toolbox, and I'm going to run emerging hotspot analysis for now. So I'll paste in that file, choose the sum of monthly oil volume as my analysis variable. And then I just need to provide a few parameters, and we can run the tool. So this will give me an idea of statistically significant assessment of how oil production is changing in the Gulf of Mexico over time. If I open up the legend here, we'll see that there are a few intensifying hotspots where oil production is increasing or has increased over the past 20 years. And we'll see that all this area that we saw production intensifying with that aggregation result is marked as an oscillating hotspot. So this is kind of a more robust assessment of that data set. So this is a pretty quick demo of GeoAnalytics in Portal and Pro, but this is a developer conference. So lastly, I want to show you how you would use GeoAnalytics in the ArcGIS API for Python. So we're going to switch gears a little bit, leave that oil use case, and now we're going to be talking about bridges. So, GeoAnalytics is not only used for complex analysis and advanced statistical things like that. You can also just use it to do some basic GIS operations, clip, dissolve. We can do all of that at scale because we've rebuilt those tools in a distributed way. So in this notebook, I've connected to my portal that's enabled with GeoAnalytics. I've searched for a big data file share called demo data, and I found 2 data sets. One is a Tiger data set of all the roads in the US, and one is a data set of polygons representing all of the water bodies in the US. And I just want to do a simple clip operation on these 2 data sets. I want to clip the roads with the water bodies to find all of the bridges in the US. Just kind of a fun, simple example. So first of all, I ran the describe data tool, which generates a statistical summary of each field in your data set to find the count of roads in that road data set. Looks like we have about 19.1 million roads. I did the same with the water bodies, and we have about, 2.2 million water bodies. So to call a GeoAnalytics tool in the Python API, all you're doing is calling a method or calling the function, supplying some parameters, pretty straightforward. And so I'll run this clip job now, and we'll see how long it takes to clip 19 million roads. Oh, name already exists. 19 million roads with 2 million water bodies. Cool. So as that's running, Sarah, do you want to talk about our new tool, Run Python Script?
Yes, I do. So we have a new tool at 10.7. So we have the ArcGIS API for Python, but we also have a new tool called Run Python Script that's exposed through REST that allows you to run distributed analysis across your GeoAnalytics server. So what does this actually mean? GeoAnalytics tools do that, but now you can do your own custom analysis. So your custom Python script that you write, you're able to use libraries that distribute analysis across your server. So I feel like a lot of these lines say the same thing when I say it, but let me skip to this one. The advantage of that is that you're able to chain analysis tools together. So right now in GeoAnalytics, when you run a tool, you run one GeoAnalytics tool and you get a result. But when you use Python through the Run Python script tool, you're able to chain multiple tools. So you could say detect incidents and then run hotspots on it, and there's only one output. There's no intermediate output. That's one big advantage, is chaining the tools together. The other is that you can use PySpark. So when you use PySpark, you're able to write custom analysis using Python libraries that are already available and open source. So you can use Spark ML, you can use SQL, and you can use data frames. So you can grab a layer that's in your WebGIS. It's automatically created as a data frame when you're using GeoAnalytics. And then you could use something like k-means, for example, on that data frame and write the result back to GeoAnalytics. This is giving you a way to write your custom analysis, integrating that GeoAnalytics server that you already have. I don't think I can stress how cool this actually is. This is something that gives you so much more flexibility with the analysis that you have, and it's also just setting up your Spark cluster for you. So something that's pretty tedious and difficult to do is go set up that server that you want to distribute analysis on. You now just have GeoAnalytics, you've installed ArcGIS Server, and you have that Spark cluster that you can take advantage of. And with that, we're going to switch back to Noah, and he will show us a bit.
Cool. Thanks, Sarah. So before I dive into the Run Python script tool, that analysis, the clip between the 19 million and the 2 million, took about 1 minute 42 seconds, and then can add the layer to this map quick to prove that we have bridges, and there they are. So that's using GeoAnalytics with the Python API, but now on to Run Python script. So like Sarah said, Run Python script allows you to interact directly with PySpark and to interact directly with the GeoAnalytics tools at the level of the code base, basically. So I'm going to run through this example of how you can change GeoAnalytics tools to avoid creating intermediate results. So bear with me here. Can everyone see that code all right? Any complaints? Good. All right, I'm moving on. So built into the environment, so when you run the Run Python script tool, a Python environment is spun up on your GeoAnalytics cluster, and a few kind of extensions to the PySpark API are imported automatically. One of those is the ability to load in WebGIS layers, or ArcGIS enterprise layers, basically, into a Spark data frame automatically. So here I have a big data file share of my CTA bus locations. This is the same data set I used in the plenary demo. And to create a data frame from it, all I need to do is call Spark read and specify the format of WebGIS. And now I now have a Spark data frame of that big data file share. And we take care of the, translating the geometry and time info so that it's persisted. Just like the plenary demo, I want to detect incidents on this bus data set and find where buses are becoming delayed. And to do that, all I need to do is call the detect incidents tool. When you run a Python script in this environment, the GeoAnalytics module is imported automatically, and each tool is a method on that object. So here, I'm just running detect incidents like any other API. I'm specifying parameters for the tool, and I'm just passing in that data frame I created by reading in that URL as my input layer. So when this tool runs, it's not going to write anything out to a data store, it's just going to return a data frame. So once this tool runs, this delay incidents variable will be storing that data frame, and I can just pass it into another GeoAnalytics tool. So I started out with a big point data set, boiled it down to fewer features with detect incidents, and now I'm going to find hotspots of those features using find hotspots. Once again, I'm just providing some parameters and passing in a data frame as the input layer, and we're getting a data frame returned as this delay hotspots variable. When I am ready to write to a data store, all I need to do is call write on the data frame and specify the format of WebGIS and an output name. And then this layer will be written to my ArcGIS, to the spatiotemporal big data store by default, but I could also write it to a big data file share or my relational data store if I wanted to. One other thing of note, any print statements that are in this will be returned as informative messages by the GP tool. So to use this, all I need to do is copy the script, and then this tool is only available in the ArcGIS REST API right now, so I'll just paste it in. I'll make sure that has a unique output name since I did run this earlier. And we can run the analysis. So we'll get some messages as the analysis executes. You'll see that that print statement I wrote was returned as an informative message. And then GeoAnalytics will start giving me messages about how many distributed tasks were completed. So these are the tasks that have been distributed to the cores of machines in your GeoAnalytics server. So it gives you some kind of idea of the progress of the job. So it looks like it's finished detecting incidents. Now it's finding the hotspots. And now a feature service layer was created and the analysis is done. So if I go to my portal, if I search for the layer, it should be there. Here we go. And it's available just like any other WebGIS layer. So this is pretty powerful because it means that you can create custom analysis workflows and avoid creating those intermediate results. Right now I'm working with a moderately sized data set, but if I had a very large data set, an intermediate result may take up a ton of space in my data store and might be totally unnecessary. So this is pretty powerful. But like Sarah said, in addition to chaining GeoAnalytics tools, we can also take advantage of the PySpark API, which is available in this Python environment as well. PySpark has a library called ML, which gives you access to a lot of different machine learning and kind of statistical analysis capabilities. For example, there's things like logistic regression, gradient boosted trees, linear support vector machines. The list goes on. Today I'm going to use k-means, which is basically multivariate clustering, which is not available in GeoAnalytics as an exposed wrapped tool in any of the UIs. But because it's in Spark ML, I can use it just like any other GeoAnalytics tool. So I have this script here. I just import pyspark.ml and the modules that I need. Once again, I'm loading in a big data file share, this time of crime events in Chicago, Illinois, and I'm creating a data frame from it. I'm then creating, preparing my data in this step here and vectorizing my X and Y columns. My goal here is to run the k-means algorithm on this crime data set to divide basically the distribution of crime in Chicago into 50 equal cluster sizes. This could be used to help show where officers should be distributed around the city to make sure that they're covering all of the expected crime events most efficiently. So once I've prepared my data, I'll fit the k-means model, transform on my data set, and then I can save the results, since it's just a data frame, out as a WebGIS layer. So we made it really easy to interface between this world of PySpark and the world of ArcGIS Enterprise. Because this is just a regular Spark cluster, I could just write out to a file share or other data source that Spark supports and totally avoid ArcGIS Enterprise altogether. But by writing to with the WebGIS format, I'm able to visualize this in Portal, etc. So I ran this job already earlier. You'll see I pasted it in to the REST API. And just like before, it worked through all these distributed tasks and then eventually wrote out a feature layer. And I'll go add that to the map now so you can see what it looks like. Here we go. I'll disable time animation and then symbolize on the whichever field had my prediction. Okay. Well, looks like I didn't prepare this demo very well, but maybe Sarah can continue and later on I can show you the result if I have it ready. But anyways, that's a summary of the Run Python script tool. If you have any more specific questions, there's a lot of details in this, so feel free to come up afterwards or go talk to us at the expo. But yeah, I'm going to pass it over to Sarah again to talk about data sources and then setting up GeoAnalytics.
Yeah, and both of those examples are actually available in the documentation at 10.7. So those are things that you can go and find and run on your GeoAnalytics server. We also realized that running these scripts through REST isn't ideal, but that's not the long-term solution. This was just, we knew that the power of chaining tools and using PySpark was so good that we didn't just want to wait until we had that IDE. So this isn't the long-term solution, but it will get you the custom analysis that you need now. And we figured that was more advantageous to you. So for data integration, Noah has mentioned big data file shares, and I'm going to talk about those as well as what other data you can use. So what types of data can I analyze with GeoAnalytics Server, and where is it coming from? So data that you have in your ArcGIS Enterprise, like feature layers, that is obviously supported. That can be data in the spatiotemporal data store or the relational data store for feature layers. Also data with ArcGIS GeoEvent Server. We've mentioned them a few times. That is a big source of ingest of data. So a lot of times people will be using GeoEvent Server, ingest their data into spatiotemporal data store, and that creates a feature layer. That can be used with GeoAnalytics as well. And we actually use the spatiotemporal data store as an output for our analysis results by default. What's additional to GeoAnalytics, and this is the big data file shares that Noah was touching on, was Hive, HDFS, and flat files. So if you just have a location somewhere on your server or a shared drive, and you have a bunch of CSVs or shapefiles, we can use that in GeoAnalytics by connecting to it. And then lastly, cloud stores as well. So Azure Data Lake, Blob Stores, and Amazon S3, we can connect to those cloud stores and create a big data file share where we're able to access that data as input. So big data file shares, these are not a requirement to use GeoAnalytics. You could just use feature layers, but a lot of people will use big data file shares, and that's what we call just those data connections that we're making. So this is your data directly from Hive, HDFS, shared folders, or cloud stores. And the actual data types that can include includes delimited files. So I think that's the most common. We see CSVs, text files, delimited files. And then shape files are also really common. ORC and Parquet are less common, but they're more common in the big data space. So we definitely see that in HDFS and Hive. Noah mentioned this as well, but what's really cool about this is that we can use multiple data sets as a single data set in GeoAnalytics. So we have a folder called Lightning here, and there are 12 shapefiles. When we register this, all 12 of those shapefiles are used as a single data set. So I'm going to browse to my Lightning data set, and when I analyze it, all 12 are used. And that's really powerful because a lot of the time you're accumulating data over time. So you get a new shapefile every month, every week, a new CSV file. As long as they have the same schema, we can use it all at once. So this is kind of a diagram that hopefully shows up for you. If not, we do have a blog post about data in GeoAnalytics, and you're able to see it there. The inputs we support, so GIS data that's in Portal, that's your hosted feature layers, stream services, and feature services, and then our external storage as well. That's all inputs for GeoAnalytics. And then our outputs, we have something new at 10.7, which is writing back to those big data file shares. So previously, you wrote your layers back to a feature service. It was an item in your portal. We realize that not everyone wants to store their results in portal. That's not the end game. Often you're going to write back to Azure Data Lake, for example, and you have someone else in your organization that's going to grab that data and go. So there's an option to choose where you want to store your data now. And as for actually registering those big data file shares, Noah showed this, so I'm not going to go into too much details, but we have a quick GIF just showing that when you are in Manager, you're able to select your file share, register the path, and we go through that manifest generation step where we look at the data, we guess the schema, we do our best guess of the schema, and then you can go change it and modify as you need. It automatically looks for geometry and time, and we register that. So the last thing we have is system requirements. Is anyone here, would you guys be the people that were tasked with setting up GeoAnalytics Server? Okay, yeah, so we definitely have some people that would be administering it. So GeoAnalytics Server is the same as an ArcGIS Server install. There's not going to be anything extra that you need. Well, there will be some extra things, but not an extra install, and I can walk you through that. So for actually using ArcGIS GeoAnalytics Server, the 4 things you would be installing are Portal for ArcGIS, ArcGIS Web Adapter, ArcGIS for Server, and ArcGIS Data Store. So as long as you have those 4 installers, you're probably ready to get started. For actually setting up everything, we recommend using 1 or 3 GeoAnalytics machines. So that means your deployment is going to look something like this. So on the left with that square, or with the rectangle, I have my base deployment. You can install that on 1 machine or many machines. That's up to your organization, and it's not really dependent on GeoAnalytics. And then on the right in the 2 circles, I have 1 machine for my ArcGIS GeoAnalytics Server site and 1 machine for my spatiotemporal data store. So again, ArcGIS GeoAnalytics Server, that's just an ArcGIS Server install, and you've licensed it for GeoAnalytics. That's all the difference is that license file. The spatiotemporal data store, that is an ArcGIS server or an ArcGIS data store install, and you configure it as spatiotemporal. The other setup would be your 3 machine setup. So 1 machine on the left, 3 machines on the right. You can see in the circle that I have 3 GeoAnalytics Server machines installed. That's all part of 1 ArcGIS Server site. So you're going to be joining those 2 and 3 machines to that same site so that when you run analysis, it knows, hey, I have 3 machines on GeoAnalytics Server, and that's how I'm going to distribute the analysis. In that case, we also recommend the same number of spatiotemporal machines. And the reason is when GeoAnalytics Server is writing to spatiotemporal, because we're writing so quickly, we want to make sure we have enough nodes for spatiotemporal data store to get all of that data and not overload it. So for actually setting it up, these steps are, the first thing is set up your base deployment. So most people will probably have a base deployment already. If you don't, there's extensive documentation on how to set up a base deployment, as well as some things like Enterprise Builder. And then when you actually get into the GeoAnalytics stage, that's when you're setting up your GeoAnalytics server. So it's an ArcGIS server install, and then you license it as GeoAnalytics. So it's just a different license file. You're going to set up a web adapter for it, because each server has a web adapter, and you're going to federate it with your portal. So just like you would do with your hosting server, you're going to federate it. And then the other step is install ArcGIS Data Store and configure it as spatiotemporal with your hosting server. And then lastly, you are going to use your portal to set which server is used as GeoAnalytics. So you're going to go to your portal settings, and then your server tab, and you're just going to scroll down past your federated servers, which you've already set up. You have your GeoAnalytics and hosting. And then right there, we're going to see Feature Analysis, GeoAnalytics Server, where you just select the one you want. It will error out if you don't have the correct license and if you don't have the spatiotemporal data store, but otherwise you'll be able to select it and use it, and those tools will be exposed right away. So as soon as you do this, in Pro, you'll see your GeoAnalytics tools. In Portal, you'll see your GeoAnalytics tools. At the REST endpoint, you'll see all those tools. For the actual system requirements, our recommendations, for your base ArcGIS Enterprise deployment, we recommend 4 cores and 16 gigs of RAM. This isn't GeoAnalytics specific. This is just for your base deployment. For the spatiotemporal big data store, we recommend minimum 16 gigs of RAM, but we do suggest 32 if possible. Some people will use 64. I don't think we see much advantage going above that. And we want the same number of machines or more, if you're really keen, than the GeoAnalytics server. And for the GeoAnalytics server, it's one site where we recommend 1 or 3 machines on there. So minimum of 4 cores and 16 gigs of RAM. There's no upper limit on the RAM, so we've definitely used 300 gigs of RAM. That's not that common. Most people will be using 32 or 64 gigabytes of RAM. And then the last few comments on the deployment. Of course, it's compatible with both Windows and Linux, and it can be deployed on-premise or in cloud. So recently we've been using cloud, for example. For the demos, we've been using Amazon this week. We do recommend, as much as possible, you simplify deploying ArcGIS Enterprise. Do not go and get a whole bunch of Amazon machines and not use CloudFormation template. That's there to help you, and it will help you. So if possible, use ArcGIS Enterprise Builder. There's also Chef Cookbooks and ArcGIS Enterprise Cloud Builder. A lot of the questions or things that come through support are easily mitigated by using these deployment things that we've set out to help you with. And then with that, I have a very quick summary. So GeoAnalytics is, oh, do you want to show your image?
Oh, sure.
Noah's going to show his image.
All right, so the symbology I couldn't get figured out later, I got figured out. So that run Python script demo I did earlier where we used k-means to predict or basically make a cluster these crime events into 50 equal areas. So here we go. And so this could be used to maybe efficiently distribute police officers around the city. So that's the wrap up. And then I'll let Sarah wrap up the session.
And now I will summarize. So GeoAnalytics is integrated. It works with your existing big data storage. So that could be Hive, HDFS, cloud stores, and your existing GIS data. So what you have in Portal is already going to work. It's spatiotemporal. So tools are designed to analyze data in space and time. You don't need time, but a lot of people with big data will have time components on their data. It's accelerated, so it speeds up your analytical processing time using built-in distributed computing. So you don't need to do anything extra to distribute things across the machines. We just do that for you. Our team really focuses on looking at those best tools, and we work on writing distributed analytics that will work for many sizes of data, different numbers of machines and cores. That's kind of what we handle as the development team at Esri. And then it's actionable. So you're able to crunch through large volumes of data to generate actionable insights and intelligence. It helps you it helps you and your organization to visualize and react to large amounts of data in a clearer and more meaningful way. And with that, we are done on time. And we have plenty of time we have 10 minutes of time for questions. So, yes. Yeah, so the question was, our setup's mostly in VMs, what would you recommend? So we personally use VMs all the time for our own testing. So with that, it would be the same recommendations as the system requirements. So 16 gigs plus, make sure that you have good network speed between them. Yeah. Yeah.
When you were creating your big data store, you described using a similar naming scheme for files. Would you be able to descend through subdirectories there?
Yeah, so the question was, when you're creating a big data file share, we had similar naming scheme for all of our files. Yes, if you have one folder at the top, you could have hundreds of different folders underneath. We will grab all of the data there. They just have to have the same schema. We don't care about the names at all. Yeah.
What about a relational style program in order to display a master relational style at different scale?
So like aggregation on the fly is what you're talking about? Yeah, so when you create feature services with GeoAnalytics, you can set it to the result to aggregate on the fly. So it's just something that would be, it's actually a feature of like the spatiotemporal big data store.
Yeah, so currently, if you want to do aggregation on the fly, so when you write to spatiotemporal data store, it's automatically going to create geohashes in the backend, and you're able to expose that as a map service. At 10.7, and we introduced it at 10.6.1, you can use the REST API and the Python API to enable default aggregations that allow you to do hexagons. So you can zoom in and do hexagons that aggregate on the fly, and we do have a blog post on that for 10.6.1 with all the steps.
There's a question here. The bridge was 66 cores across 3 machines. And then I think we had about a good amount of memory, like 8 to 10 gigabytes per core. So this is a beefy deployment. It's kind of like, scaled out scenario, but definitely not necessary to have that much capacity. Usually at Esri we test with like 8 cores or 12 cores at a time. So
the job will use the same amount of cores every time though. So when you're running GeoAnalytics, it's preset to use a certain amount of percentage of your resources. So you'll say, I want to use 80% of my cores. So every job will use the same amount of cores.
Yep. Question over here.
So as far as the file performance, do you recommend using auto scaling so that you can scale up and scale down? You said no.
No, we do not recommend auto scaling right now. It's not something that we have. You can definitely turn off your GeoAnalytics server and turn it back on, but we are saying 1 or 3 machines for GeoAnalytics.
Yeah, because GeoAnalytics seems like pretty on command.
Yeah, right now we don't have auto scaling. We're definitely looking in to see how we can do it. But yeah, right now it's 1 or 3 machines. Yeah.
Would you say that GeoAnalytics could be implemented into a real-time workflow? So, along with geo events, taking, small subsets of large data and, having GeoAnalytics do the analysis, on that.
Yeah, so the question was, could GeoAnalytics be integrated with a GeoEvent workflow? And definitely yes. We work with stream services, we work with feature services. As long as we can use that data, you could be automating running the tools over and over when needed. Sorry. Are there any more questions?
One over here.
Sorry.
You said you used 1 or 3 machines. What are those numbers?
Yeah, so underlying process, there's Spark and Zookeeper. And just in the big data world, Zookeeper, there's leader election issues with 2 machines. So we just don't recommend even numbered machines. And then 1 and 3, we've just found is most stable at this point, but we're looking at expanding in future releases. Cool. Well, thank you so much. We will be available here and at the island after if you have any more questions.